Good morning, students. So, the next topic is soil classification. So, soil classification is the arrangement of soils into different groups such that the soils in a particular group have similar behavior. Okay, so for a soil classification system to be useful to the geotechnical engineer, it should have some of the basic requirement. That is, it should have limited number of groups, and it should be based on engineering properties which are most relevant for the purpose for which the classification has been made. And also it should be simple and should use the terms which are easily understood. Okay, and next is the objectives of soil classification. First, we are doing the soil classification in order to arrange various types of soils into groups according to their engineering properties. Okay, next is it is considered as a system of labeling soils which would convey the same meaning universally, and it should be possible to grade the soil for its suitability for a specific engineering project. So we can identify a soil if we are classifying it into different groups. So we can classify the soil based on its engineering property and its appearance, etc. So next is principle of classification. So general classification as coarseless and coarsive, or coarse-grained as fine-grained, and it is too general and include wide range of engineering properties. Okay, so this is again subdivided into different groups, and additional means of categorization are necessary to make the terms more meaningful in engineering practice. So there are several classification systems which is involved by different organization having specific purpose as the object. Okay, so there are different types of classification which is based on particular types of specification, and they are Indian Standard Classification System, Unified Classification System, ASTO Classification System, etc. But in your syllabus, only Indian Standard Classification System is included. So we can study in IS classification of soil in detail. So IS 1498-1970, that is classification and identification of soils for general engineering purpose. So according to this IS classification, soils are mainly classified into three main categories, that is coarse-grained soil, fine-grained soil, and peat. Okay, that is the main classification. And here this coarse-grained soil is again categorized into 8 groups, and this fine-grained soil is again classified into 9 groups, and there is peat. So altogether there are 18 groups under this IS classification system. Okay, that is mainly soil is classified as coarse-grained, fine-grained, and peat. Then coarse-grained again subdivided into 8, and fine-grained again subdivided into 9 groups, and last one is peat. Coarse-grained soil means that is the soil in which more than 50% of the total material by weight is retained on 75 micron ISA. That is, if more than 50% of the material is retained on IS 75 micron, it is coarse-grained soil. And when more than 50% of the total material passes 75 micron ISU, that is fine-grained soil. Okay, and peat means it is highly organic soils and other miscellaneous soil materials. So this is the IS classification based on grain size. So we have studied about this classification. Okay, that is the particle which is less than 75 micron, it is fine-grained soil, and this fine-grained soil again divided as silt and clay, and the particle with the size greater than 75 micron, coarse-grained soil, it is again divided as sand, gravel, cobbler, and boulder. Okay, this we have studied in the previous classes. So this table shows the prefix and suffix for IS classification system, that is gravel. Gravel is indicated by this letter prefix G, sand S, silt M. Okay, silt is not indicated by S, silt is indicated by M. Okay, clay by C, then organic O. Peat is indicated as P suffix P small letter T, PT. Okay, then this is the main classification, main group, and there is subgroup like well graded. If it is well graded, it is indicated as W. Poorly graded, P, and silty means M. That is, silty is classified as M. Then silty also indicated as M. Okay. Then clayey, C. Okay. And if the liquid limit is less than 35%, L, and liquid limit between 35 and 50 I means intermediate, and this which is greater than 50, it is H. Okay, highly organic. So we can discuss it in detail. So this shows the classification of fine-grained soil. So fine-grained soil means if more than 50 percentage passes 75 micron ISE, it is fine-grained soil. Okay, if more than 50 percentage weight of the soil particle is passing 75 micron, it means the particle will be fine. So it is fine-grained soil, and this fine-grained soil is again divided as low compressibility, intermediate compressibility, and high compressibility based on liquid limit. Okay, so the index property of fine-grained soil is Atterberg limits. So based on this index property, we are classifying this fine-grained soil. Okay, generally soil is classified based on index property. So for classifying this fine-grained soil, we are using Atterberg limits. Okay, that is low compressibility means if the liquid limit is less than 35 percentage, and intermediate compressibility means liquid limit is greater than 35 percentage but less than 50 percentage, and high compressibility means liquid limit is greater than 50 percentage. Okay, so this is the main classification of this fine-grained soil, and this low compressibility is again subdivided into three groups. This is again subdivided into three groups. This also again subdivided into three groups. Okay, and in your Aurora textbook there is a table which showing the classification of fine-grained soil and coarse-grained soil in page number 100 and 101. Okay, if you have that textbook, please go through that pages. I'm also included in the coming slide. And this is known as plasticity chart. This fine-grained soil is classified based on this plasticity chart. So I will explain this plasticity chart in the next slide. So this is plasticity chart. So this is plasticity chart. So this plasticity chart is actually used for classifying this fine-grained soil. Okay. So plasticity chart is plotted by plasticity index on y-axis and liquid limit on x-axis. Okay, so plasticity index means the difference between liquid limit and plastic limit. So here we are drawing a straight line at a liquid limit 35. Okay, so this is that line, and also there is a straight line for liquid limit 50. Okay, and this is A line. Equation of this A line is plasticity index IP is equal to 0.73 liquid limit minus 20. Okay, so we can plot a straight line if we know 2 points. So for getting these 2 points, we can put any two values for IP and WL, that is x and y. Okay, so if we put x as 0, and then we can calculate what is y, and also give some value for x and then calculate y. Okay, like that we can calculate 2 points, and using these 2 points we can plot the curve for this straight line. That is, this is passing with 20. That is, if we put liquid limit as 20, in equation you can see if liquid limit is 20, what is IP? This will be 0, so IP will be 0. Okay, so one point is 20, 0. That is, if liquid limit is 0, this plasticity index become 0 by this equation. So this is 1 point. Okay, so this is 1 point. So for calculating another point, we can put some value for this liquid limit and calculate IP. So we can note 1 point here. So we can draw this straight line. Okay, so this is the procedure how we are drawing this A line. And above this A line, the soil is in this portion, that is above this A line between 0 and 35, the soil is CL. CL means inorganic clay of low plasticity. L means low, C clay. So inorganic clay of low plasticity is indicated as CL. And between 35 and 50 and above A line, the soil is CI. CI means inorganic clay of medium plasticity. Okay, so this second term actually indicates the range of plasticity. So here it is low plasticity, here intermediate or medium plasticity. I means intermediate. Okay, that is inorganic clay, that is clay of medium plasticity or intermediate plasticity. And here it will be clay with high plasticity, CH. H means high. Okay, so this is the classification of fine-grained soil based on plasticity. And below this A line, the soil may be, here it is ML or OL. ML means it is inorganic silt. M means silt. I have told for indicating silt we are using the letter M. So ML means inorganic silt with low plasticity. Silt with low plasticity, that is ML. Then OL means organic silt. Organic silt with low plasticity. Okay. And MI, here it is MI, that is between 35 and 50 and below the A line, the soil is MI or OI. MI means silt with intermediate plasticity. OI means organic silt with intermediate plasticity. OI, organic silt of intermediate or medium plasticity. And here that is greater than 50, that is after this 50 and below A line, the soil is MH or OH. Okay, MH means inorganic silt of high compressibility. Then OH means organic silt with high compressibility. Okay, so this is the classification of fine grained soil based on this plasticity chart. So if in examination it is asked to classify the fine grained soil using this liquid limit and plasticity index, first you can draw this plasticity chart. Okay, so for plotting this plasticity chart, first draw this straight line for 35 and straight line for 50. Then after that you draw this A line. Okay, so A line will be first point will be 20 0, because we have put liquid limit as 20, so by that we will get IPA 0. So this is one point. And next we can calculate any other next point by putting some value for WL and calculate the corresponding value for IP using this equation. Okay, like that we you plot this A line. After that we can classify the soil, whether the soil is falling here, 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 or etc. Okay, so it will be clear after doing one problem. I will do problem in the next video. So after that you will be clear about this plasticity chart. Okay. Next is the coarse-grained soil, classification of coarse-grained soil. So coarse-grained soil means if more than half of the material is larger than 75 micron ISU, it is coarse-grained soil. And this coarse-grained soil mainly subdivided as gravel and sand. Gravel means more than half of the coarse fraction is larger than 4.75 mm ISU. Sand means more than half of the fraction is smaller than 4.75 mm ISU. So that is sand. Okay, and this gravel is again classified as GW, GP, GM, GC, etc. GW means well graded gravel. GW means well graded gravel. GP means poorly graded gravel. Okay, and GM means silty gravel. M means M indicates actually silt, so silty gravel. And GC means clayey gravel. Okay, so before discussing about this classification, you should by heart the term that we have discussed earlier, that is G means gravel, S means sand, M silt, C clay, O organic. Okay, that should be thorough. That is W means well graded, P poorly graded, M silty, C clayey. Then L means low plasticity, I intermediate plasticity, H high plasticity. So this is for fine grained soil. Okay. So for coarse grained soil, this gravel again subdivided as well graded gravel, poorly graded gravel, then silty gravel and clayey gravel. Okay, then likewise sand is again subdivided as well graded sand, then poorly graded sand, then silty sand, clayey sand. Okay. Then GW, well graded sand means here CU, that is uniformity coefficient will be greater than 4. And CC, that is coefficient of curvature, is in between 1 and 3. Okay. And GP means there is no meeting all gradation requirement of GW. And in GM and GC means here Atterberg limit. Atterberg limit will be less than 4, that is IP, that is plasticity index will be less than 4. Like that. So all these classification is in your textbook, Aurora textbook. So I will share the notes. Okay. So this is the primary division, coarse grained soil. It is divided sand and gravel. Okay. GW well graded, same. GW means well graded gravel. GP poorly graded. GM silty. And GC clayey gravel. So this is the subdivision of gravel. And next is sand. Sand is again subdivided SW, SP, SM and SC. So this is the main classification of coarse grained soil. Okay. So this table shows classification. This is in your textbook. Okay. So this is about the soil classification. So in the next video I will do some problem based on this soil classification. Thank you.